Hi, and welcome to today's video where we are going to be looking at equivalent ratios today. So what you can see here is I've got a couple of ratios on the board, and I just want to draw your attention to a couple of things. One, you can make equivalent ratios both smaller and you can make them larger. We're going to actually do that today with both of these ratios and show you an important concept about what equivalent actually means in terms of the value of these ratios. So one thing you'll probably need to remember is that ratios and fractions and decimals and percents are all the same thing, they just look a little different. And if that concept is a little bit confusing, I will walk you through why they're the same thing in just a couple of minutes' time. Hopefully it'll clear things up. So before I get started, I just want to recommend that if you need to pause this video at any time, it would be a great strategy for you to help you learn. If you need to watch again, by all means do so. If you have any comments, questions, or something is not clear, just drop a comment down below and I will get back to you and try to work things out with you. So let's take a look at the first ratio here. What we have here is a ratio of 5 to 15. And what I want to do is create an equivalent ratio that, we'll start with a lower. So I'm going to put the lower ratio on the top. If I want to make both these numbers smaller, what I want to do is I want to divide both this number and this number by the same thing. Okay, now I want to work with some friendly numbers here. I want to work with numbers that are going to be whole numbers. That way I can guarantee that they are going to be equal because I have whole numbers here. Okay, so I don't want to necessarily divide 5 by 2 or by 2.8 or something like that. It just becomes a little harder to work with the decimal. I mean, it is possible that you could do it, but let's work with whole numbers. Let's work with friendly numbers. So this one's relatively simple because I can see here that both the 5 and the 15 end in the number 5, which means that I can really only divide by one thing. I can divide by 5. So what I'm going to do is show that. I'm going to divide by 5 here, and I'm going to divide by 5 here as well. And what I have is 5 divided by 5 always gives me 1. Any number divided by itself will always equal 1. And then I have 15 divided by 3, or 5 divided by 5, and that is 3, leaving me with 1 to 3. Now you might think to yourself, well, how is that equivalent? Like 1 and 5 are different, and 15 and 3 are different. This is where solving the value comes in. If I was to take 1 and divide it by 3, or if I had the fraction 1/3, for instance, and I divide the top by the bottom or divide the left by the right, I'm going to get a value. I'm going to get how much that is worth. And in this case, this is worth 0.333 repeating. And if you took 5 and divided it by 15 or changed it to a fraction and divided the top by the bottom, you're going to see that you're going to get the exact same thing. The value is going to be the same. Now, this value means that this ratio and this ratio are equivalent. They both have the same value, even though these numbers are different. The value of them is what stays the same. That matters. Now let's work the other way. Let's make a larger equivalent fraction, and it's really important to remember that whatever number I'm going to multiply the left by or the right, I have to multiply its opposite by the same number. So if I can't multiply 5 by 2 and 15 by 5 all of a sudden, okay? Because then what it does is it changes the value when you do the division and check your answer. So keep the numbers the same. So let's pick any random number. Let's pick, let's go easy. Let's go 4. I'm going to multiply 5 by 4, and that's going to give me 20. And then I'm going to take 15 and multiply it again by the same thing. I multiplied the left by the 4. I'm going to multiply the right by the 4. And 15 groups of 4, or 4 groups of 15, is equivalent to 60. And now if I want to check to see if it is equivalent, what I would want to do is take the 20 and divide it by the 60. Because I took the 1 and divided it by the 3. I took the left divided by the right. I took the left divided by the right. So I'm going to do the same thing here. Left divided by the right. And you're going to see that the number is going to be decimal 333 repeating, showing that each of these, even though they're different numbers, they are equal. They are equivalent to each other. Okay? And that would be the same as if I transferred all of these into fractions. Maybe I would have 1 to 3, maybe I would have 5 to 15, and maybe I would have 20 to 60, and they are all the same. They are all equivalent to each other. Okay? Let's swap over to blue. What we have here is 8 to 16. Now I know that if, what I'm going to do is I'm going to try to again use friendly numbers. I need to think of a number that goes into 8 and 16. Well, immediately I can think, well, 2 does. So I'm going to divide by 2. Divide by 2. If I take 8 and divide it by 2, I get 4. And if I take 16 and divide it by 2, I get 8. Now I can even make that smaller. I know that 4 goes into 4, and I know that 4 goes into... So I'm just going to show you a couple of different equivalent fractions here on the lower end and show you that they're all the same. The value is going to be the same. If I take this and divide it by 4 and then divide the 8 by 4, I end up with 1 to 2. Now if I want to check the value of it, I know that 1 divided by 2 is equal to 0.5, which is the same as 50%. Okay? If I take 4 and divide it by 8, I end up with 0.5. It is the same. It is also 50%. If I take 8 divided by 16, I get a value of decimal 5, which is 50%. They're the same value, even though the numbers are different. And I can do the exact same thing. I might make this larger. Maybe I'll multiply this by a friendlier number. I'll multiply it by 10. And some kids ask, well, where does this number come from? This number comes from when you're making them larger, just whatever number you want to use, as long as you're remembering the concept of multiplying the left and the right by the same thing, you will get an equivalent fraction. Or an equivalent ratio, rather, remembering that ratios are the same as fractions. So I'm going to multiply this by 10 as well, and I will end up with 80 to 160. And then if I take and check the value of it, 80 divided by 160, that's going to give me decimal 5, which is the same as 50%. So as you can see, it really all depends on this value here to determine whether or not your ratios and or your fractions are equivalent. So that's it for today's lesson on equivalent ratios. If you need to go back and rewatch the video, please do. If something didn't make sense or jive with you, by all means leave a comment below. Don't forget to subscribe so you don't miss anything, and thank you for watching.